Today's lesson, okay. Today's lesson is angle of contact and properties of matter in physics. Yes. Let's see what is angle of contact. This is another important part. Mostly this year A-level essay will be from this part. I mean, properties of matter essay. Okay, let's write down the topic, angle of contact. Angle of contact, theta. I'll show you what is angle of contact, but let's first write down a definition. The angle forms between a liquid and solid. Where it's between the tangent and solid surface. Within the liquid is called angle of contact, or just simply contact angle. There are special points. Angle forms between a liquid and solid where it is between the tangent and solid surface within the liquid. Very important. Very important. I'll explain you why it is important. Let's take examples. Now think you add some water into a capillary tube, because in big containers, in large containers, you will not see meniscus, a clear meniscus. These meniscus are especially seen in very small tubes or containers, like a capillary tube. If you add water, it forms a meniscus like this. Clearly, it forms a meniscus like this. Now, what is contact angle? You draw a tangent to this point where liquid meets solid. Let's draw a tangent. Wait. Okay. Let's draw a tangent. Okay, this is the tangent. It says Now look at the definition. In the definition, it says angle between the tangent, where angle you draw the tangent to the position where the liquid meets solid, and the angle is between tangent and wall, the surface of the mass solid. Okay, and now if we just say that in the previous definition, I mean in the syllabus, the definition was only that, but it's wrong. Why? When they say angle between tangent and the solid surface, you can draw two. One is this, one is this. You can say theta and theta. They are not equal. So if we just say angle between tangent and solid surface, which it was there in the syllabus, it's wrong. Why? There are two, but contact angle is only one. That's why I add the theory part. It should be the angle within the liquid, inside the liquid. So contact angle is this. This is contact angle. You can draw in the other one. This is 3D. Ne? Although I just draw these two, and these two, you know, this is 3D. You can take circularly the contact angle. It's the same. Theta 1. Contact angle. CA. We say in literature, in experiments, research, we say CA. Water contact angle WCA. In research papers, university level, PhD level, we say WCA. Okay. You can just take down a small diagram to see what is contact angle. Even my my undergraduate level research project was to make a super hydrophobic surface, which is a self-cleaning surface. I made rubbers and some other materials which are self-cleaning. Their contact angle is greater than 150, so they repel water and all bacteria and everything. They remain dry and self-cleaning. So there I did work with this contact angle a lot. Here for a water droplet on a in a super hydrophobic surface, it will be like this. So contact angle will be like here. Contact angle is like this from here to here. Solid surface to tangent through the liquid means this. This is also contact angle. You can take this down. There are proof. I mean, using Lavoisier Laplace law, we can prove this, but I don't go to that part. Using the surface energy, surface tension, forces, we can prove contact angle and everything. We will not do that. Give me a second. Okay, this is what contact angle is. Then let's draw another diagram. Contact angle theta. If the now we learned what are cohesive forces and adhesive forces earlier. So we can say if the adhesive forces are greater than cohesive forces, surface will be like this. You can draw tangent, and this is the contact angle. So we say the meniscus is a concave meniscus. Concave meniscus. And we say contact angle is lesser than 90 degrees. Contact angle is lesser than 90. So it's a wetting scenario. That means the liquid wets the surface when the angle is lesser than 90 degrees. It's a wetting scenario. If now here the interactions between water molecules and if you take this as the solid is glass, the attractions between glass and liquid are greater than liquid. If it is water interaction. But if the other way happens, that means uh, if the cohesive forces or cohesive interactions, cohesive forces means interactions between same particle, equal part. If they are greater than, stronger than adhesive forces, adhesive force, it will be like this. Like this. Draw the contact angle and theta is now surface to tangent through the liquid means like this. Theta is a big one. Meniscus is convex. Convex meniscus. Convex meniscus. Contact angle is greater than 90 degrees and this liquid will not wet this surface. Non-wetting scenario. If the solid is glass, normally Mercury acts like water acts like the left scenario, and Mercury will act like the right scenario. That's the idea. That's what you should take down.
Okay.
That's about contact angle variation in different liquids. Actually, not only liquid affects the contact angle, even the type of solid, changes. Because the type of solid changes the contact angle. Okay. Then new point, write down a new point.
Hmm.
If soap is mixed, to water, the surface tension as well as contact angle decreases. Then the membranal nature of the liquid decreases, of the liquid decreases, where
Then the membranous nature of the liquid.
yeah, when the membranal nature of the liquid, that of water, we are talking about water, of water decreases, where it goes through the dirt, where it goes through the dirt, and does cleaning action, does cleaning action. Okay, you can take down this diagram. It shows now with the membranal nature of water cannot go inside the dirt and clean it well, but just water. But when you add softener, some soap or anything like that, surface tension decreases and cleaning effect increases. And in another way, yeah, that's true. And in another way, if you can remember, what happens if you heat a liquid? Still, when you heat a liquid, still the surface tension decreases. Again, when the surface tension decreases, this cleaning effect increases. So one is you can do it by adding soap. The other thing is you can heat, and even by heating, you can increase the cleaning effect more. Okay. That's the idea. Then let's take down more points like where contact angle is 0, theta. Oh. Contact angle equals 0. You can draw it. It's like this. Maybe we can't draw it exactly, but where it contacts, if you draw this, the angle will be, I mean, the meniscus is through there's no angle between meniscus and tangent. Contact angle 0. And contact angle 90 option scenario. Theta equals 90 like this. So where if you draw the tangent, angle between tangent and surface through liquid is 90 degrees. Can take down these two. And normally, if someone asks, how can you make a surface hydrophobic? Or how can you make a surface non-wetting or self-cleaning? This is somewhat extra knowledge, but it's better if you know this. Now, surfaces. Normally, the surfaces we see are hydrophilic. Hydrophilic means it likes water. No double way. It likes water. It is wetting. Surface is wetting. Water can wet it. We can make, and sometimes naturally we see hydrophobic surfaces. If we think about water, water cannot wet the surface, non-wetting. It's non-wetting. Okay, give me a second, you can take this down. Hello.
Hello.
So yes, this is about wetting and non-wetting of a surface. So hydrophilic means the liquid wets, especially not just any liquid, it's water. Water wets the surface. Hydrophobic means it doesn't wet the surface. Then uh, next one is for this to wet the surface. Surface has some. Now the type of liquid affects the type of surface affects surface of the type of liquid affects the type of surface affect. With the type of liquid and surface, due to the interactions, adhesive and, as we explained earlier, due to adhesive and cohesive forces, it will control whether it's hydrophilic or hydrophobic. That's the story. Then let's go to hydrophobic side. It's non-wetting. And here contact angle is lesser than none. Non-wetting. Both they're the same thing. Liquid and surface effects. And theta is greater than 90. Do you know how we now normally in industry? I mean in industry sometimes we want to make surfaces hydrophobic. So we have to control two things. One is surface energy. You have to decrease surface energy. Two is you have to decrease surface tension. It's same thing. It's actually same thing. And another thing, increase roughness of the surface. Increase roughness of the surface. Actually, both of these are same thing. Don't take it as two. You have to decrease the surface energy. That's one. Other thing is increase the roughness. Make some asperities, roughness, nano roughness. With the correct equilibrium or balance of surface energy and surface roughness, we can achieve hydrophobic nature. When it is hydrophobic, it's self-cleaning, it is non-wetting, it remains dry. Interesting, you can just see in YouTube hydrophobic products. We can make shoes, clothes. I made some clothes and rubbers that even we may put it into water, mud, a swimming pool to a mud, a puddle of mud, nothing remains. It remains dry and no difference is shown. And colors don't, in washing or anything, colors, actually no need to wash. no dirt or stains or anything is there, and color doesn't deteriorate. There are many more advantages when we make a surface hydrophobic, and there is more like as super hydrophobic. If it is super hydrophobic, contact angle is greater than 150 degrees, then it's great. You can take down if anything is there, then I'll show you some more things. This is some extra knowledge, but your question, if your question is mainly targeted on contact angle, they will give you some statements on hydrophobicity, philicity, and discuss. Okay. Okay. Then I'll erase this. And next thing is, you can see natural hydrophobic surfaces. Where can you remember? Do you know? Lotus leaf. Lotus leaf. Naturally super hydrophobic. And there are some wings of insects, because otherwise when their wings becomes wet, they can't fly. So, but let's only take lotus leaf. There are some other types of leaves also. If you check its nano, if you magnify the surface, you will see on the surface there are asperities, high roughness, nano or micro level roughness. Then what happens? Then the surface energy decreases, but it's not only the solid. Here there's air. There are air gaps. So it's a some game with this surface energy, interactions, adhesive, cohesive forces. No need to think that much more. So with the air gaps, it's not like a solid. In when there's air, surface energy is less surface energy. You know, but I taught you some extra things in the beginning, that how the air particles and liquid surface interactions are lesser, you know, because I taught you more, but no need to know everything. These are extra, but it's important. So water droplets are like glass droplets on the surface. No wetting happens. So the surface becomes water now. In a normal surface, water is like this. If you put a water droplet on your table, water droplet is like this. So the contact angle is from here to here. Contact angle is lesser than 90. Hydrophilic type, wetting. But here, if you draw, this is contact angle, greater than 90. Hydrophobic, non-wetting, hydrophobic. And especially if the angle is greater than 150 degrees, we call it, if it is greater than 90, hydrophobic. If it is greater than 150, we call it super hydrophobic. Super hydrophobic. Normally in research and development in science, technology, now we make super hydrophobic surface for new requirements. They are non-corrosive, they are non-stainable. There are many more. So self-cleaning, there are many more advantages of a super hydrophobic surface. So what we should do, decrease the surface energy and increase roughness. Both happens due to these asperities, roughness. Is it clear?
Yes.
You can take it down. I think that's enough. There is another science called superhydrophilic. Superhydrophilicity, the contact angle is lesser than 5. We use that technology to make circuits new, the modern circuits and everything, because it keeps a nice, very thin layer of anything we put to that surface, but it's too much for A level, so I don't talk about that. Okay. Natural,
Yes.
you can see
Yes.
naturally superhydrophobicity in lotus leaf. It doesn't wet. Even you put water in rain, it doesn't wet. It just repel water as perfect. And some insect wings and like that. Okay.